Good evening, ma'am. Good evening, ma'am.
Good evening.
I'm just coming up.
Yeah, no problem. I just joined. I thought I should get a seat, So I joined. No problem.
Okay. Hello, Riesel. Good evening. Riesel, you can hear me? Why she's gone away. Hello, Riesel.
Yes, good evening, ma'am.
Good evening. And where is Alsona? Why she's not joined?
Ma'am, I'll just check. Good evening, Principal, ma'am.
Good evening. All the best.
Yes, ma'am, thank you.
Good evening, Dr.
Hi, good evening. I'm just trying to work out on my camera and position my laptop.
Yeah, sure.
Good evening, Dr. Haneet Gandhi.
Hello, ma'am. How are you?
I am fine, thank you. So you are welcome, most welcome. Nice to see you.
Thank you, ma'am.
So looking nice with a nice dress.
Okay. Yeah, thank you.
Okay.
Thank you.
So
I'm
ready?
just, yeah, I'm just adjusting my camera so that,
Yeah.
it's all in place. Just give me a few minutes to,
Okay, okay. No issue.
and I'll start my slide sharing. I'll just roll that.
Okay, fine.
Yeah.
Resel, I can't see Alsona.
Ma'am, she is joining. She just messaged on group.
Alsona, which one should I make the co-host?
Alsana, we can't hear you.
Hello,
Yeah, which one should I make
Yes.
the co-host?
ma'am. Make the one which I'm talking. No, my full name. That one.
So Father Blaze is joining in some time, and then you all manage the waiting room. Huh?
Yes, ma'am. Now it is 3:45. So should I send the link on group?
Yes, yes.
Okay. So also now you admit people, okay?
Yes.
Yeah.
Please look for Father Blaze. He's going to join.
Yes, ma'am.
So now,
Yes, ma'am.
Father Blake is seen in the waiting room.
No, ma'am, I can't see Father Blaze.
You will be able to let him know if he.
Yes, we have space.
I can see 100 on my screen. That's all.
Yes, but we have not admitted all, no? We have just admitted 91.
Oh. Dr. Haneet,
Yeah, hi.
hi. So ready, no? We'll be beginning in a short while.
Yeah, sure. Yes.
Hello.
Okay. So it is 4 o'clock. Ma'am, can we begin now?
Yeah, I think so. We can start.
Okay. So good evening, all the participants, and welcome to the Mathematics Webinar Series 7 on teaching mathematics with a multidisciplinary perspective. I would request Dr. Susama Samuel, Principal of St. Xavier's Institute of Education, to welcome all of us. Over to Dr. Susama.
So, good evening, everyone, and a warm welcome to St. Xavier's Institute of Education. Our manager, Father Blaise D'Souza, my colleagues, faculty members, students, and participants from different parts of our country, different part of our state, all are welcome to this webinar series. Welcome to St. Xavier's Institute of Education once again.
Good evening, ma'am.
This webinar series, the main topic for this is teaching strategies and solutions for boosting mathematics. This webinar series is an initiative of our mathematics pedagogy unit, which is headed by Dr. Bini Sebastian, Associate Professor from our institute, and the team of mathematics pedagogy students. There are 7 students are also a part of this webinar series. It is a monthly webinar series. Monthly, there is one session based on mathematics and subjects related to mathematics. And the main purpose of this webinar is to promote mathematics and to develop interest in mathematics and to reduce the difficulties of the students related to mathematics and to make mathematics more creative, more interesting to students as well as teachers. This is the 7th session and the 7th session related to this webinar series. The past 6 sessions, so 6 series dealt with various pedagogies of mathematics. Some of the sessions dealt with some research products, the findings of the research, and some of them were like mostly it was based on the pedagogies of innovations or pedagogies of mathematics to develop interest in mathematics. And the resource persons, the last series were from college teachers, from schools, experts or teachers from schools, as well as from colleges, as well as from various institutes, like some of them were from Indian Institute of Technology, IIT, and some were from Homi Bhabha Center for Science Education. So this webinar series is for the last 6 months. It is running very successfully. And the purpose of or the objective of this webinar is to promote mathematics or to develop interest in mathematics in students as well as in teachers. And today's topic for the session is something which is very important. I can say that the current topic, that is teaching maths with a multidisciplinary perspective. As we all know that the most distinguished quality of mathematics is that mathematics is an integral part of our life and an unavoidable part of our life, as well as it is an integral part of any subject. Mathematics is essential in our life, as well as mathematics is essential in developing any other subject. Sometimes mathematics is a tool, sometimes mathematics is a discipline, sometimes mathematics is a pedagogy, sometimes mathematics is an innovation, sometimes mathematics is related with values. So we can say that mathematics is everything. Or one thing we can say that mathematics is an ingredient of any product. So whatever product you see, that mathematics is a part of any product, or mathematics is a product, is a part of any finished work. So today, Dr. Haneet Gandhi will share her knowledge and her experience with us in this subject. I think multidisciplinary approach, she is very much interested in sharing her knowledge with us. Today's her topic is teaching mathematics in a multidisciplinary perspective. Let us together welcome Dr. Gandhi to this session. And also I welcome our mathematics unit head in charge, Dr. Winnie Sebastian, and her team of students. When she started this webinar series, we started with a lecture series or a presentation, but after some time now she has also put some innovation in this, and now she has taken up need-based research along with this. So I think monthly this team conducts a need-based research, and also I hope that at the end of the session she share the findings with us. So good going for mathematics unit, Dr. Vinny Sebastian, and your team of students. So I appreciate on behalf of the institute for the good work you are doing. So all the best to all the participants, and all the best to Dr. Gandhi, and all the best to Dr. Vinny Sebastian and team of students. So over to Dr. Vinny.
Thank you, ma'am. Before I start, Alsona, father is waiting in the waiting room. So can you please look out for Father Blaze?
Yes, ma'am. Okay.
Okay. So thank you, ma'am, for your motivating words. And ma'am has always been very motivating to the mathematics unit, and that has helped us to move forward till now. As ma'am has already given us a background, SXIE has St. Xavier's Institute of Education, the Mathematics Pedagogy Unit, has been organizing these webinars on strategies and solutions for boosting mathematics learning. We have been doing this since June 2020, and we have garnered a lot of interest in this mathematics webinars, because when we did not have it in December, I got a number of calls saying that, ma'am, why have you not had it in this month? You know, we really wanted to hear this any on a topic of interest, of our interest in mathematics subject. So I think we have done a good job, and by conducting these webinars, we hope and pray that there are some changes that are happening in the attitude and perception of mathematics teachers, and some innovative pedagogies have been practiced in the schools and colleges. So we are truly grateful to all the resource persons, the participants, and all the institutions that have collaborated with us for organizing this webinar series. We have really got a very positive response every time when we have organized these webinars. And this time we have got over 700 participants who have registered for this webinar. We request you to share your 1-minute video of your innovation on the mathematics learning at sxi.in. The email ID is provided to you. So please share your 1-minute video. We would be uploading it on our mathematics channel. It is an open educational resource, and it can be of use for everyone. This meeting will be recorded, and it will be uploaded on our YouTube channel, Mathematics Learning. So do subscribe to our YouTube channel. This effort would not be successful if we did not have our own students standing by us. So I am really grateful to our student team, Riesel and Alsona, who are the co-hosts for today, Clarice, Nisha, Rachel, and Wasim, who will be helping today. And we also have Daya, who's not present, but she has been helping in our mathematics webinar. So today we bring to you an innovative perspective, teaching maths with a multidisciplinary perspective, by Dr. Haneet Gandhi. So before we get into the session, I would request Riesel to introduce Dr. Haneet Gandhi for us. Over to Riesel.
Yes, thank you, Winnie ma'am. Good evening, everyone. Today we are privileged to have with us Dr. Haneet Gandhi to speak on teaching mathematics with a multidisciplinary perspective. Dr. Haneet Gandhi is a faculty in the Department of Education, University of Delhi, and is an expert in mathematics education and quantitative research methods. Ma'am has completed Masters in Mathematics from IIT Delhi and PhD in Mathematics Education from Lucknow University. Dr. Haneet Gandhi has authored several books on the teaching of mathematics. The famous among them is the series on Hands-on Mathematics for Middle School Children. As an academician, ma'am wishes to break the myths related to fear of mathematics by connecting ideas in an easily comprehensible way. Ma'am has, to her credit, many national as well as international publications in reputed journals that are widely referred to. Dr. Gandhi has also held many important positions at the University of Delhi. In 2019, Ma'am was appointed as the co-convener for revising all undergraduate and postgraduate programs under the Learning Outcome Approach of UGC. Currently, Ma'am is appointed as a Deputy Dean in the Admission Branch of University of Delhi and is handling admissions for the current academic year 2020-21. Ma'am, we are delighted and pleased to have you with us this evening. Once again, a warm welcome on behalf of St. Xavier's Institute of Education and a kind request to begin your session. Over to you, ma'am.
Thank you so much. Am I visible and am I audible?
Yes, yes.
Yes, ma'am.
Okay. So thank you so much to the St. Xavier's Institute for inviting me in these web series. In fact, very recently I came across this institute and I'm privileged and also I'm extremely excited and honored to be part of these web series, especially something related to maths education, because not many people work in this area. I mean, now I see an upsurge in on the works related to maths education, but for a very long time there were hardly people who were working in this area. So I'm very excited, and my congratulations to St. Xavier's College of Education and particularly to the Mathematics Pedagogy Department for taking this initiative, inviting people like us to be connected with your institute, knowing you and knowing other people. As you said, there are around 700 participants. That's huge, and that's really applaudable on your team's part, that your students and all of you are working as a team to make such webinars successful. And 700 people across country, which will span across teachers and students, and I'm sure teacher educators. So you're doing a great job in educating people, especially in maths education, which has not been, I would say, it's been a slightly unexplored area. Not many people work diligently in this area. So I'm really happy, and many congratulations, with my folded hands to all of you who are working in this field and promoting mathematics education. So I'll begin my presentation. There are a couple of things I think I'm supposed to do. So let me just do those little, can you please allow me to share my screen?
You can share now.
Right. Just to give you a little background on what I'll be talking about, I will be soon sharing my PowerPoint presentation that I've made specially for this webinar today. But most importantly, that has been a concern, and people who join today, I can request them to look into it, how we understand mathematics and mathematics in our country. Okay. We need to really do a lot of research is available, but
Please mute your mics, participants. Please mute your mics. Yes, ma'am. Please continue.
thank you. So we definitely need research in maths education per se, particularly to particularly to the context of our country. When we look at researches done in this area, most of them we have to rely to the researches which have been done outside our country, and sometimes they don't help in making out sense of it, or contextualizing it. So my earnest request to all the participants who are here today is to please look into thematic things, look into the conceptualization of mathematical concepts, look into how we can build this learning of mathematics amongst our children. We've had such a rich culture. If you go abroad, or if you go somewhere abroad, and you say you're from India, the first thing that comes to their mind is that we're good in mathematics. But in the late few years, we're seeing that this is dipping. The love for mathematics, or we as Indians, we kind of, the passion for doing mathematics is kind of declining. I think it is for us now to look into and introspect why it is being done. Anyways, today I have something else to share, which is on multidisciplinary perspective. And is my screen? Okay, 1 minute. So let me just share my screen.
Share the computer sound also, ma'am.
Yes, thank you for reminding. And are the annotations also off? Any idea? Let me just close the annotations as well. Okay, can you see my screen?
Yes, ma'am.
Right. Is it full length now?
Yes.
Okay. So the topic that I'm going to talk today is about teaching mathematics with a multidisciplinary perspective. Now, there is a term which is being used here, multidisciplinary. And, since we're all teachers and we love to talk in our classrooms, this online teaching or, online talking doesn't seem to be too enthusiastic. So I request you all, and I request the organizer to open the chat boxes, and please tell me, because my, I won't be able to look at the chat boxes and my screen is on. And this will be a two-way process. I'll post certain things and I'll wait for you to chat and to give certain responses. When I've got a handful of responses, I'll move ahead. So that's how I'm going to take this talk today. So today we are going to talk about how to teach mathematics from a multidisciplinary perspective. But to do that, we need to first understand this term multidisciplinary. What do we mean by multidisciplinary? So I throw this question to the house. There are three terms which come very close to each other. One is interdisciplinary, multidisciplinary, and transdisciplinary. So, organizers, please help me. Should we take it in the chat box, or shall we let the people allow them to use their mics? But I want you to please tell me some key things on, how do you differentiate between them? What do you mean by multidisciplinary, interdisciplinary, and transdisciplinary? Being in education, it is extremely important for us to discriminate or at least understand these three terms. So, organizers, please help me. How do we take this ahead? Shall I?
Yes, participants can unmute themselves or they can write on the chat. We have Nisha and Rachel who will be helping you to see what is on the chat. Nisha and Rachel, would you be helping, ma'am?
Yes, ma'am.
Yes, ma'am.
Okay. So I request the participants, you can even pick up. I've been told that this is coming live on YouTube. So if you have any idea, if we do not get any responses, then I will move ahead. But let me wait for a couple of seconds to get some feedback or some responses from the participants. How do you understand these three terms? How do you look at these three terms?
Ma'am, there are a lot of responses. So,
Okay.
ma'am, they have told that multidisciplinary means involvement with students in all topics.
Okay.
The other person has told multidisciplinary means people from different disciplines working together, each drawing on their disciplinary knowledge. They have told interdisciplinary means integrating knowledge and methods from different disciplines using a real synthesis of approaches. And transdisciplinary means creating a unity of intellectual frameworks beyond the disciplinary perspectives.
Great, great. I hope people are not picking up from the YouTube, from the Google. I hope they are like all understanding what they're saying, because then I can delve into the various terminologies that they're using. But yes, even if you're Googling, it is fair enough. And these are fairly good ideas that we've got. Any more responses?
There are responses from the YouTube. So Rachel and Nisha, would you be able to pick up that?
Yes, ma'am.
Yes, ma'am.
In YouTube, people are saying that interdisciplinary means maths and accounts and economics.
Okay.
Someone says it means the same disciplines, while interdiscipline means in the same discipline, while multidisciplinary in multiple disciplines.
Okay.
Poonam says multidisciplinary basically to coordinate or bring co-relationships among teaching learning process.
Okay.
And another response is multidisciplinary is related to several branches.
Well, yeah. So very close answers. I'm very glad that people are writing very closely knitted answers. Yes, these terms are similar. So let me just clarify for the people who have not participated or they have any confusion in it. You see, interdisciplinary would mean that within a discipline itself, you are looking into the connections in a very layperson manner. If I could tell you, I mean, I'm talking to people who've just entered into the field of education. Let me bring it to that level. So when you're looking, which means in all three of them, you need to first understand what do we mean by a discipline. You know, there is a framework, there is a structure which defines a discipline. So if you understand what you mean by discipline and you understand how do you inculcate that habit of working into that discipline, only then you'll be able to understand these three terms: inter, multi, and trans, because you know these are like adverbs adding to that noun of discipline. So first and foremost, you need to understand the paradigms of a discipline. What makes the structure? What is the nature of a discipline? Mathematics has a very unique structure. In fact, you know, you would always get into this kind of debate whether maths is an art or maths is science. You know, you always, I mean, this is the first assignment that I give it to my B.Ed students, that please write a write-up on whether you think maths is an art or maths is a science. So I give them examples to think mathematics as an art. You know, so if we first draw, what do you mean by a discipline, an art discipline, and what do you mean by a science discipline? I'm not going to give you the answers because I want you to look into it from your own perspective. But it's very important that you first understand mathematics is as a discipline. Is mathematics more towards humanities, arts, or is mathematics more towards sciences, or does it have a unique structure of its own? Once you've understood, for me, I think it has a unique structure of its own, and I have my reasons which I'm going to tell. I mean, I'm going to delve into those in my presentations. I'm going to use all that, what I'm saying, why I think that maths is neither a science nor an art. It takes it from there, but it's a unique way of doing things. It's extremely abstract. It's a matter of mind. It delves into the mind. We work from our mind, and then we start working in an abstract way. There is a principle of logic which builds onto the mathematics. There is an inductive process. There is also a deductive process. You know, all these things are very important in the disciplinary attire of mathematics. So after you've understood, you know, what do we mean by mathematics per se as a discipline, then you understand what is it connected with. You know, what are the traits that mathematics share with other disciplines? So to that extent, you can talk about, let's say, physics. Sometimes they say maths is more related or bent towards physics, or physics is more bent towards mathematics. If you take those as a disciplinary affirmations, then probably you're talking about an interdisciplinary approach. However, if you take physics, arts, and sciences as something separate from the disciplinary structure of mathematics, then whatever you would be doing, you'll be talking about a multidisciplinary approach, because now you will look into all these disciplines as distinctly featured. So you'll talk about physics as a distinct feature in altogether. Chemistry has a distinct disciplinary aspect. Sciences will have a distinct disciplinary aspect. Languages will have a distinct disciplinary aspect. And when you try to make connections between all these, and mathematics then you take as a distinct disciplinary aspect, and if you try to bridge all of them, then perhaps what you're trying to bring out is a multidisciplinary aspect. Transdisciplinary aspect, you know, it's like transmodifying. So you're talking about something which comes out new from all these associations. For example, artificial intelligence is now being talked as a transdisciplinary aspect. It draws from various disciplines, but it is now building up into a new discipline of its own. And there could be, you know, after a couple of years, we might see artificial intelligence as built up in a unique discipline way again, you know, and then you might say that this has emerged as a discipline. So that there is blurredness in these terms. It depends, so how you bring it up. But the foremost thing is to understand what is your understanding of a discipline. So I urge you, if you are not too familiar with this term of discipline and you do not know how to justify or differentiate between discipline and subject, first and the foremost thing for you to do is to read some good books on education and clarify this thought. Any person who is in the field of education or even general must be able to differentiate between, or must be able to identify the structure and nature of a discipline. I mean, I can't go on and on because I have to do many things, but what I want to here emphasize is, please understand the aspect of discipline, and then only you'll be able to understand what do you mean by inter, multi, or transdisciplinary. In this presentation, or in the next 1.5 hours that I have, I will be focusing more on multidisciplinary, which means for me, my understanding is that maths has a distinct feature and other subjects also have some features, and I'm going to take an amalgamation of these. It's like, I'm going to try to merge out or bring out mathematics from these different areas, which means that I'll have to give you examples from how maths is a product, is a byproduct, or could be brought out from other subjects. We have to see, when we're looking at a relationship between the two, then I will have to bring out in a multidisciplinary. Sometimes maths would be feeding into that discipline. Sometimes I will be taking things from that discipline and bringing it into mathematics. So if you understand this little framework in your mind, then things would be easy. That's one. Second caveat to my presentation before I begin is I'm going to throw many examples to you. All right. And as Dr. Vinny has said, I would urge, after looking at the YouTube, you bring out certain, or you take these ideas and then make some lesson plans, or see how you can bring out these ideas and take it to your children and bring out your lesson plans. How would your pedagogy, what would your pedagogy, of course, I will bring out some nuances of making a lesson plan, but ultimately it is the teacher who's empowered to take these ideas and build on it. So you can take this as a project. Once you've seen these examples that I share, these are just glimpses, internet is full of examples. But I'm going to show you another perspective of using these examples. There is obviously, you just have to read and connect mathematics with it. Once you get the knack of it, then see how you can bring these perspective or make lesson plans for your students. Now, each of these ideas can be used at any level. You can see from class 3 to class, let's say, middle school, 10th and 11th, you can use any of these ideas, depending about how much rigor you would like to bring, how much profoundness you would like to bring. You can use any of these ideas. So I'm going to give you like a buffet of ideas, and you can then, it's up to you to pick whatever and, explore the world around them. Okay. So as we were looking, I would like to start this idea why we need to look at mathematics from a multidisciplinary perspective. We need to go and look into the history. History, if you look back, when you look into the evolution of ideas, while I'm talking about history, I'm not talking about historians. I'm talking about evolution of ideas. So for example, if you look at how mathematics or disciplines emerged, how the concepts emerged in the past, then you would understand what the need of being a wider and thinking about from a multidisciplinary perspective. No subject emerged in isolation. If you go to the ancient history, let's say about ancient Indian history, the examples that you see in my screen are all talking about mathematics. If you look at the left hand side, there is an altar. People used to do a lot of yajnas and a lot of things they used to do in the ancient India, especially down south. And there was a need to do all these religious and rituals exercises. There was very fine-tuned ideas that would be brought up. Then they used to make these altars on the ground. And it involved a lot of mathematics, including Pythagoras theorem, or including, where is the direction of the sun? How do you make perfect angles? How do you make perfect squares? How do you then study the motion of the planets, and where, in which direction should you place it. Now there is a lot of literature available on this, but and similarly, if you look at the right hand side, that is the building of Jantar Mantar in Delhi. So they were capturing the motion of sun. They were seeing how they can find time as accurately by just looking at the motion of sun. Now in India, if you go a little into the evolution of ideas, you would say that there were 4 dominant civilizations. There was this Indus Valley civilization, Egyptian civilization, Mayan civilization, Babylonian civilization, Chinese civilization, these Greek civilization. These are some of the civilizations which we talk about whenever we talk about doing mathematics. But that's it. We just say that maths is being developed was developed in Egypt. Math was being developed in Indus Valley civilization. Zero kahan se aaya? Zero, shunya ka jo concept hai, that was Indian or was it Western? What we feel or what we do not do is we do not connect it to other things or which were happening around them. What led to the discovery of these ideas? What led to the discovery of, let's say, zero, or the idea of talking about zero? Why was zero invented in India? Why? What was the need that us, we had no choice. We had to come up with this idea of zero. Anybody could have. Why couldn't Egyptians or the Roman system that you talk about, Roman numbers that we write is 1, and then we use 2 sticks to do 2, and then we write 1, 2, 3, 3 sticks to do 3. And then we look at 4, which is 1, and then V, and 5 is V, and 6 is V, and then 1. Isn't it strange that, how did they came up with this? How did they thought of this idea of, writing these sticks and, subtracting 1 from -5 to get 4, and then you add 5V plus 1 to get 6, sorry. It's very intriguing. And why could not they think of zero? So if you add, let's say, now you don't do it, but when we were students in class, I remember in our textbooks, we used to learn all these numeral systems, but it just stopped there. We were never led to add. So I give you an exercise. For example, if I ask you to write 562, I'm randomly saying 562 and add it to 378 in Roman. So first you'll have to bring this number to the Roman numeral system. Think you are living in Rome and you have to add. So you'll have to first create those symbols and write 562 in Roman symbols. And then you add. I don't know whether you will be using a column-wise addition, or you will be using, a horizontal way of writing the numbers, and you will be adding. Well, that's up to you how you look at it. There is a lot of things that one can do. But just think about it, that they did not. There is no symbol of zero. Roman were never talking about zero. We were talking. We had to come up with the place value system. Why? Obviously, there was a need. We were doing lot of things on the astronomical level. We were doing big calculations, and we were doing very small calculations with respect to the infinite, the anu, the concept of atom. So science was helping us. Astronomy, the study of astronomy we were doing. We were looking into the passage of these planets and stars. We were studying those astronomical spaces. We were studying stars. So we were doing long calculations. We had to. That led to the idea of place value. हम कर नहीं पाते अगर हमारे पास नहीं होता. हम अगर रोमन सिस्टम के हिसाब से कर रहे होते तो हम add, subtract, multiply नहीं कर पा रहे होते. We would not have been able to add, subtract, divide, and do things like that had we not introduced a place value, and had there not been a concept of zero, or a placeholder, if I may call it. The zero came out as a number in the Indian system because we were doing our rituals, because we were doing things which were related to big numbers. So maths was not isolated. Even then, we were doing chemicals, we were studying them, we were looking into building of houses. So we had to come up with these ideas. There was no escape to it. You see, so there was a need, there was an evolution of concept. Please remember, there was an evolution of concept that led to mathematics. It was intermixed. One led to the discovery of others. So if you could do this, you could do then other things. Okay, let me take this to another concept, which was, if you look at just the Egyptian way, Egyptians are also, they were also doing a lot of mathematics from the ground, from geometry, they were doing a lot of things, which means study of the earth. They also, if you just simple example I will give you, just to tell you, why we need to look at, I'm just laying the foundation of my talk. I've just not even started my talk. If you see the middle row on your screen where there are symbols written, there is a symbol for 1, there is a symbol for 10, there is a symbol for 100, there is a symbol for 1000. So their script, the heliographic script, was using these symbols to write numbers. How they were writing numbers, there's a different workshop that I can do, or any one of you, or you can even Google it and read it from internet. Importantly is, why were they using these symbols? How was language being held? How did they think of this inverted? You're seeing it as inverted N, or N, sorry, inverted U or N, but that was actually the horseshoe, the horseshoe that we use. Hundreds is actually a coil. It's a coil. And 1000 is a lotus. And 10,000 is a finger. Let me move to a big number where you see a person standing like this, that was a symbol of a king or a pharaoh. What was happening? They were not using these numbers. For them, there is a lot of literature which talks about why they were using these symbols for doing it. So for example, 1. Now 1 is being, it's just a stick. That was universal. Many people were using 1 as a stick. Horseshoe, which means when you have a cluster of 10, then they replaced it with a horseshoe, which meant that if you're a peasant, you would be needing a group of people. You would own a horse probably. So if you have 10 servants under you, you probably also have a horse. If you have a horse, then that means you have almost 10 people working under you. So there was a context which gave birth to this symbol of for 10. A coil was bounding people together in a group. So if you could manage to have an army of 10 people and pull a thread around that, which means you could rope them around, that means you have something related to 10. So a normal farmer or a normal peasant would not need a coil, all right? He would, or she would, females were not even working. So that person would only be, at most working with a horseshoe. So he needed only a horseshoe, which symbolized 10. Coil would be perhaps like a zamindar or a landlord who would have people around him, and he would need rope to measure his land. So they use the rope to indicate 100. Let me move ahead. Then I'm going to go to that last symbol. I don't have time to go to this history or the conversation of other symbols. Let's look at the king. A king was the most powerful person, and only he would need numbers as big as this. Nobody else would, this is like the king of kings. Only he would be using a big number of 10 raised to power 6 or 10 raised to power 4. So only he was allowed to use this number. That is why it had a symbol like this. Common man were not needed. They didn't need it. So since they don't need it, it never came to them. So you see now, what I'm trying to tell you is there's again a multidisciplinary perspective here. This has drawn from the art of symbolization and semantics. The numbers or the number sense or the numerals or the connotation of symbolization drew from there. So आज अगर हम 1 को ऐसे लिखते हैं, 2 को ऐसे लिखते हैं, there are many WhatsApp stories which come up, about angles. They're not bullshit. They're all rubbish. No, please go into the history and then you will see why 2 is being symbolized as this and 3 is symbolized as this and 4 is written like this. Very interesting. And then go on and foremost, then, I was talking to Dr. Vinny in the afternoon and she reminded, in fact, I would take this example. I told her that unless we understand the evolution of concepts, we will not be able to create a justified space for our students to learn them. Unless we create a need to learn them, we can never do justice to their learning. So what led to, let's say, the idea of integers, minus sign? For 100 years, there was a debate. Mathematicians could not think of a number like -1. They had lot of debate. They could not think. And, when we are giving in our examples in the textbooks, when you're giving examples like, -1 is when you go towards left side, the number line, it starts from -1, -2, so on and so forth, or the lift going up and down. I'm sorry, but these examples have actually diluted the whole idea of doing mathematics. The integers never came up like that. The idea of -1, if you read history, it wasn't like this. There was a need to create it. And that need came from an interdisciplinary perspective. Now, I'm not saying multidisciplinary here because after a while, from multidisciplinary to coming to interdisciplinary. Now, what happened was the idea of number of -1 emerged when people started doing algebra. So when they were doing algebra, to find the answer of x -1 is equal to 0, what value should you put an unknown number, which when subtracted from 1 will nullify the result, was easy to do. X -1 is equal to 0, तो x निकालना आसान था. बता सकते थे आप x क्या था. लेकिन इसी इक्वेशन में अगर मैं चेंज कर दूं और लिख दूं x plus 1 is equal to 0, it was crazy for mathematicians to think at that time. ऐसी कौन सी वैल्यू x में 1 में डाली जाए जिससे रिजल्ट फिर 0 हो जाए. They said, this is vague, this is absurd. You are anti-theist, you are this, you are that, you are outcasted and blah, blah, blah. It happened. And gradually it worked out that, if you have to bring it out, if you say what, then that was the idea of -1, that -1 plus 1 is equal to 0. So you add -1 to 1, which nullifies and brings it to 0. But yes, there were a lot of debates, and for many years, even mathematicians were not ready to accept it. तो अगर mathematicians नहीं accept कर पा रहे थे, तो -1 का concept अगर हम class 6 के बच्चे को सिखाते हैं, तो क्यों दिक्कत आती है? उसके pedagogy में, उसके psychology में, there is a reason. Why children do not understand fractions is because fractions are built up on years of understanding. Integers are built up on years of human struggle with the ideas. So anyway, there are aspects. So what I wanted to tell you till now that please be open in accepting mathematics as multidisciplinary, transdisciplinary, but as a discipline itself also. Okay, let me move it. Any questions till now? I'm happy to take, or organizer, please tell me if I can move on.
Ma'am, no questions yet.
Okay. And how much time do I have? All right. Okay. So there are a few videos that I've been making in this lockdown. I'd like to share a few. This is like a teaser, a commercial break for all of you. If you've been hearing from me for quite some time, a short commercial break for all of you. I'm going to show you a video, 2 minutes video. Let's see if you have this. And then I'll pause this video in between and I'll ask you to answer, all right? So this is something that I'm trying to create, and let's see if you have a mathematical eye. So I'll just start this video.
Welcome friends. In this episode of Do You Have a Mathematical Eye, we're going to see if you...
we can't see, sorry, we can't see the video.
Okay.
So you have to stop sharing and share.
I have to?
Try again, we couldn't see the video. We could hear it.
Oh, okay.
Click on it once again, just say.
So do I have to share now the video screen?
Yes. Share the video screen.
Oh, had I known this earlier. Okay, anyways.
Because
I'll toggle. All right, I'll toggle in between. Oh, this will be a bit of a task. Can you see the screen now?
Yes.
I for chai, can you see that?
Yes.
All right. So, Vinny ma'am, what I'll do is in between, I'll stop it for the participants to respond.
Yeah.
But after 1 minute of this video in any case is 1 minute 26 seconds. So I think I'll have to stop after maybe 50 seconds or something. Okay.
Welcome friends. In this episode of Do You Have a Mathematical Eye, we're going to see if you have an eye for chai. So if you're a fond tea lover and like to have your tea through tea bags, you would have noticed that there are different shaped tea bags available in the market. There is a pillow shaped tea bag, a pyramid shaped tea bag, a circular shaped tea bag, and a stick like tube. And here's the challenge. For the same amount and quality of tea leaves, which of these shaped tea bags will give you a better brew? Do you have a mathematical eye for the shapes?
Okay, so so what I've asked in this video is, among the three shapes, the triangle, pyramid, and the square, which tea bag, for the same amount of tea bag and quality, of course, which tea bag will give you a better brew, which will give you a better taste of tea? Okay, so over to the organizers to please give me some responses.
Okay, I think we can read out the responses, Rachel.
Yes, ma'am. Ma'am, the chat box is flooded with responses,
Okay.
and we have maximum responses as square, followed by pyramid, then triangle pyramid, and the minimum responses are for circular.
Okay, very interesting, and I'm so very glad that people are listening to the talk so very carefully. Okay, let me share my thoughts on this, and I'm switching on the video. So if you know what you've done, you've actually made a conjecture. All of you have made a conjecture. That's the foremost thing of thinking mathematically. Let your students make conjectures. All right, you've not proved it, you made a conjecture. Okay, congratulations everyone. Let me just switch on the video.
The quality of tea depends upon proper brewing of the tea leaves and of course the quality of tea leaves. When we add hot water to the tea bag, the tea leaves in it swell, they move in a circular motion and ooze out their flavor. More space will ensure a better brew. The pyramid shape just qualifies to be a better shape and it gives enough space for the ingredients to unwind, infuse and expand properly, releasing maximum flavor. By using the pyramid-shaped tea bag, the manufacturers are actually in a win-win situation. They use less material, they use less amount of tea leaves, but get a better brew. And of course, the shape of the pyramid is so attractive that it can be made expensive. Hope you enjoyed this little maths in your cuppa. Chai time!
Okay, so I'll end it here.
Welcome friends. In this episode of Do You Have a Mathematical Eye? We're going to see if you have an eye for chai.
Okay, so so what we've done here, I hope you liked it. I've just tried to explain. Sorry, let me share my. So I'll have to toggle, right, Winnie ma'am? I think
Yes,
I'll have to.
yes. Stop share first and then share again.
Yeah, all right. I hope I don't do any mistake.
No, take your time, ma'am. Just stop share.
Yeah.
There is stop share, no, on top red button.
I'm trying. I'm just trying. So stop. Yeah, I've stopped sharing. All right. Okay, back. So so what we've done, what I'm trying to say is, um, you have tea every day, but which is the most economical shape that you would use? And people gave their answers, and then there are I mean, this I'm sure this you would have thought, and you would have tried to think, which is a better one. And this is something that you do every day. People are very fond of shapes. Every day we see shapes around us. What we fail to do is connect it to the mathematical, small little mathematical ideas. Why? If we're talking about, let's say, if we're teaching about similarities, or we're talking about three-dimensional shapes, we teach it in such isolation and don't even think about making it connections to real life. Don't even think about connecting it to from a mind. So this had the idea of when I'm talking about that the tea leaves swirl around, they swell, and then they swirl around. There is a motion, there is physics attached to it. There is chemical formula which is taking place when the tea leaves get attracted and they hit the warm water. Understand that, and then only you will understand why they're swirling around, what happens, understand the kinematics of the liquid, and so on and so forth. So you can actually bring up a project on, what happens, and then observe it, make a video of it, and, there are a lot of things that you can do. Anyway, so let me go ahead with my presentation. This was just one example. Let me go back to my presentation. I'm going to share a couple of more examples. Is my screen visible now, the PowerPoint?
Yes, yes.
Okay. Right. So, yeah. Right. So every day you find a lot of connections of mathematics with other subjects. And I was just going through your earlier talks, and I came across the web series 6th episode, in which Dr. Jayashree Subramaniam had spoken about mathematics that happens every day. She talked about ethno-mathematics, where she brought a point on how mathematics is connected to culture. Those also give us very beautiful examples of connecting mathematics, to our different cultures. I'm sure she gave you an example of mathematics that happen in a pawn shop. There are a lot of things that a person is selling. There are a lot of negotiations that are happening on the commercial sense. How this child thinks about the profit. If there is a man or a person who's sitting at the pawn shop, how she or he negotiates between the different articles which are kept in that shop. Even then she or he knows how to bring out a profit. So that's an idea of mathematics which is happening every day. Something that I do with my students is we take them for a walk to this market of potters, and I ask them to look at how these potters, how beautifully the potters will just take a blob of mitti, and with this circular thing which is going on and on this disc which is rotating so fast, they bring up a shape which is so symmetrical in shape. But don't stop there. What happens is कि हम इतना सा देख कर कि अरे मैथ्स बहुत अच्छा सिमेट्री हो रहा है, इस आर्टिकल में सिमेट्री बताओ, and we just stop there. Don't do that. If you have to bring out mathematics to its true sense, please go beyond it. Let children come back and then give them the shape. So, ask them कि अगर मेरे पास एक square है, and if let me see. Okay, I'm sorry I was not prepared, but since as a teacher you evolve your teaching also. Suppose this is a sheet of paper, and I have a thin wire which is going around on here, and on this thin wire I can put an electronic thing which can circulate it. I've done this with my class, with my B.Ed students. So agar is wire pe, if I rotate this like this, on this wire, what shape would you get? I'm sure this is a very simple answer. Everybody knows it gets a cylinder. Now if the wire is placed here, again I'm going to rotate it on this wire. So this is here, and I'm going to do what you will get. You will again get a cylinder. That's fine. But of these two cylinders, which will have which will have more volume, or which on these will have more surface area? Talk about that. Okay, now let me go beyond it. What if I put the wire from here diagonally, and I rotate it like this? What shape would you get? This is extremely interesting. And if you can, so if I do this in with lot of, so suppose I have a disc like this with the potters use, and on that potter's disc I place this little sheet of paper with a string of a string going diagonally from here, and I rotate it with a lot of speed. I mean, I can't do it through my hand, but imagine it is like circulating. What three-dimensional shape would you get? Do you have a name? Or just imagine, just close your eyes and imagine that from a paper diagonally attached, if you are rotating it, what shape would you get? So that's how shapes came up, three-dimensional shapes came up through this axis of rotation. And then, suppose it's not a plane. I'm not doing it from here. I just pierce it through the center, and I rotate it like this. What would you get? And why? So you start moving from one dimension to two dimension through three dimension. And I do this with various shapes. अभी स्क्वायर उठा के देखते हैं, अभी रेक्टेंगल उठाकर देखते हैं, अभी इसको हम एक ट्रेपीजियम उठाकर देखते हैं और उसके डिफरेंट साइड से उसको रोटेट करके देखते हैं. Sometimes you will not even have the name for the shape because it's not there in the textbook. But students can describe you that shape. They can tell you. For example, this rectangular thing, or if I ask you on a rectangle, this piercing from the center and rotating it like this, give me the answer. Think about it. I'll tell you the common answers that you will. We don't have time because I have to move ahead. Common answers that would come up is a square or a disc or a circle, sorry, or a disc, but that's not the correct answer. So if you were planning to give disc or a circle, that's not the correct answer. So do it and then post your answers. Anyway, so you pick up from what the from the potter's market and you delve into the mainstream mathematics and you start talking about how mathematics is, these shapes evolved. And carpentry. A lot of examples, these are some examples, and I'm sure Dr. Jayashree Mathur had shared many things which happen in ethno-mathematical way. I also saw that she talked about columns and, the way females make integrated designs by just using those rice atta, and they make, go on and on and on. Those are actually Euler's graphs, basically, So this is, and I remember when I was a child, my grandfather used to give me a lot of examples. He used to say, "Ye banao bina haath uthaye, or bina ek line ke upar dusre line." Those were games for us, but they were integrated Euler's graphs. Columns have that, that kind of a mathematical inbuilt in it. So you take mathematics from there. Anyways, I'm not going to go into ethno-mathematics because you can watch Jayashree's video for that. And this is what I plan to do, that if you look at columns, they look like this, and then you go on and you make such integrated designs, which are actually Euler's graphs. I'm skipping this because Jayashree had already done it. However, coming back to the multidisciplinary perspective, I cannot, go, I can go here and there, but I have to come back to my multidisciplinary. Why did I pick ethno-mathematics also in my multidisciplinary? Because mathematics also has a social contextual flavor in it. There was a reason why our cultures, or there were reason why we were doing columns. So please understand, let your children take up a project on not just looking mathematics in the column designs, but also looking at what it meant, what it means to make a column. Why are these shapes used as columns? What was the cultural background? Why is it like this? Or even, in Northern India, we make rangolis before Diwali. Obviously, there is a tradition of decorating our house, but it's not just that. This ritual was not only just to, make a good design and decorate your house. Columns, when they were making a single stream without picking up their hands, and they're making such beautiful designs. Why? Who taught them? Who taught these ladies? And their ladies were, taught by their grandmothers, and then grandmothers would have been taught by their grandmothers. I'm sure there is a cultural connection. And if you understand that cultural connection, you would understand why they were making these designs and what it meant for them. That is the perspective that we need to bring up. That it is not just related only to science, but also to aestheticness. When I say maths is an art, and mathematics is also an art. So you need to not choose to do mathematics in terms of Euler's graph. Euler took it up. Euler was not doing columns, of course. So Euler did only graph theory. But our females are making only art. They don't know Euler's graph theory, and Euler did not know column. Let's marriage them. Let's create a connection between them. As teachers, we need to make a connection. We know what is there in the disciplinary mathematics. We know what is happening in our context. We know what is happening with our students. We know from the background that they're coming from. We can connect it. So if you have potters, a village near your school, or there are a lot of students who are coming from that background, please merge it. Please take it ahead and do it. That's what multidisciplinary approach is about. Please take it together and take the benefits of each field and go ahead and charge, just barge, just go. Okay. Are you ready for another episode, a teaser? Can I start another? So this is mathematics and biology, which is another one of my videos. So let's take a commercial break and see if we have a mathematical mind, and can we connect maths and bio also. So can I do this? I think I'll have to stop sharing and then again go back. Right, Dr. Vinny?
Yes, yes.
So sorry for this toggling.
You can
I think I don't have a choice. So
you can click on that channel.
yes, I'm doing that. And once it's on, I'll. Today we're going to talk about patterns on animal skin. So I'll share the screen. Can you see the screen?
Yes, yes.
Okay, great. Here's it.
Hello friends. Today we are going to talk about patterns on animal skin. Animals have varied skin textures and patterns. If I ask you to name an animal which has spots on its skin, probably you will tell me a leopard. And if I ask you to name an animal which has a striped body, I think a zebra would come to your mind instantly. Let's come to the interesting part of it. What about their tails? Is the tail of a leopard spotted or striped? Is the tail of a zebra striped or spotted? Do you know of an animal which has a striped body but a spotted tail? Do you have a mathematical eye?
Okay. So I've asked you a small question about the tails of animals. You know that there are spotted animals like a leopard, which has a spotted body and a striped tail. Do you know of any animal which has a striped body and a spotted tail? I think I'll go ahead because it's not a very simple one. Are there any responses or shall I go ahead?
Ma'am, no responses. The participants are thinking.
There won't be because there isn't any animal like that. All right. So let me tell you why. So the answer is not why we, sorry?
Ma'am, there's one response.
Hmm.
It's Dalmatian dog. Dalmatian dog.
Dalmatians. No,
Dog.
it also has a spotted. No, please. So I'll switch on the video. And this has got again to the, let me just give you a prelude to it. Again, I'm going to talk about volumizing and spacing of molecular structures. That's the theory behind it. But let me do it in a very, very softer way, not too much of mathematics. So here's the answer.
Well, it's quite possible of an animal to have a spotted body and a striped tail, but it's not likely to have an animal which has a striped body but a spotted tail. And mathematically, one can explain this. The person who gave logic to computers also gave a differential equation in which, by changing the parameters, one can explain this conjecture. The man is Alan Turing. In simple terms, Alan Turing's theory of morphogenesis goes something like this. Two chemicals, let's call it a reagent and a diffuser, interact to influence skin patterns. If the reagent stimulates the production of one color, the diffuser suppresses it. There is also a relationship between the shape and size of the skin area on which this reaction occurs. Squarish regions of roughly the same overall area give rise to spots. Long, thin regions lead to stripes perpendicular to the length of the region. This reaction diffusion process takes place at the development of the embryo. Since the embryo of a zebra is thin, pencil-like, it leads to stripes. Whereas leopard's embryo is fairly chubby and therefore gives spots. Its tail, however, is thin and pencil-like, so the resulting pattern is stripes. This is how nature can be explained through mathematics. Love nature, love maths.
Okay, so...
Hello friends. Today we are going to talk about patterns on animal skin. Animals have varied skin textures.
So I'll stop sharing and yes. So this was again understanding nature and there are a lot of things, this is one example of animal's body. You can even look at, there are a lot of things you need. I mean, people who are in maths know about fractals, and there is self-similarity. Then there are also examples of Fibonacci series in nature. But what we do not do, when we're talking about fractals, we say that, maths to matlab nature ke andar hai, or maths is so divine. We need to understand why there is spiraling in the Fibonacci. We say fractals mein hai or self similarity, लेकिन वो self similarity leaves में बनी क्यों है? उस एस्पेक्ट को समझिए, और उस एस्पेक्ट समझने के लिए आपको बायोलॉजी भी देखनी पड़ेगी, आपको मोशन ऑफ सन भी देखना पड़ेगा, लीव्स का स्ट्रक्चर देखना पड़ेगा, ज्योग्राफी पढ़नी पड़ेगी, डेमोग्राफिक उसको समझना पड़ेगा कि क्यों पाइन्स की शेप इस तरह की होती है कि वो स्पाइरलिंग बन रहे होते हैं, and leaves are like thin like in some demographical area, or they're broad, and then why they are broad, and then what happens. So the space, volumizing, the shape, along with all these things will bring out the flavor of any subject, any discipline. So it's not just looking maths, biology. Please look at how they come out as in a multidisciplinary aspect. So can I move ahead to my presentation, back to my presentation?
Yes,
Any
ma'am.
questions, or would you like me to take a few questions in between? Or shall I go ahead?
Ma'am, currently the chat box is flooded with appreciation posts from the participants. So there are no questions yet. So ma'am, you can.
I think yes. So please make some notes. I'd be very happy to take your observations, and thank you so much for your appreciations. Okay. So let me go ahead. All right. Now, another aspect that, many teachers and many students ask us about integrating art. In fact, actually CBSE ने शायद अभी 11th-12th में कुछ भेज दिया because of, online classes. Because, I see lots of WhatsApp chats being flooded with maths और art का connection क्या है. तो कनेक्शन है, लेकिन कनेक्शन को हम सिर्फ आर्ट और मैथ्स में ना छोड़े, उसके अंदर जाकर भी ढूंढे कि क्या कनेक्शन आता है. एंड द ब्यूटीफुल एग्जांपल व्हिच आई कम अक्रॉस इज रिगार्डिंग टेसिलेशंस. There are 2-3 articles which I've published related to tessellations. I don't have time to go into that, but I'm just going to a glimpse. I'm just going to till now you've understood my pedagogy of this webinar. I am, hitting and moving on. और वही मैं भी यहाँ भी करने वाली हूँ tessellations में भी. Tessellations are small motifs. In simple terms, it's called tiling, which you use it in your bathrooms and everywhere. So there is a small motif, and that motif gets multiplied on the plane. Now it's on a plane, all right? I'm not talking about a 3-dimensional space. वहां पर tessellation की बात नहीं होती है. एक प्लेन के ऊपर एक छोटा सा मोटिव जिसको आप इनफाइनाइटली रिपीट कर रहे हैं और उसमें कोई गैप ना हो. तो ये जो फिगर्स आपको दिखाए हुए हैं, ये सारे तो नहीं, except the left hand side, they are from some other temple. I'll tell you the name of the temple because that's full of these tessellating tiling. But apart from these two on the left hand side, the others that you've seen were taken pics which were taken in and around Delhi. This includes Viceregal Lodge of Delhi University. This includes Chandni Chowk. This includes a Red Fort, and this also includes Bangla Sahib. And the small picture where you're seeing those feet, 2 feet है end में, वो metro line के tiling patterns हैं. Metro जो Delhi metro में जाती है, वहाँ का जो pavement है, उसके tiling patterns हैं. So you see these, there is a small motif which is repeatedly iterating itself infinitely on a plane. This is where, many people stop that it has similarity, it has symmetry. And many teachers take examples that, you look at transitivity symmetry, you look at rotational symmetry, you look at glide symmetry in these tessellations. But that's not the pleasure of doing it. The fun of doing it ki glide symmetry क्यों है, rotational symmetry क्यों है, कौन सी ऐसी शेप थी जो रोटेशनल सिमेट्री बनी, वो सोचिए. तो सिर्फ सोचने का नजरिया बदलना है कि क्या शेप थी कि ये ग्लाइड सिमेट्री में आ गया, क्या शेप थी कि उस टेसिलेशन में रोटेशनल था. So if you do a little bit of reading on how this beautiful art is connected to a mathematical thinking, you will talk about shapes. You will talk about, there are 3 shapes that tessellate in itself. which are triangles, squares and hexagons. I'm talking about regular shapes. अभी irregular shape पे जाएंगे तो बहुत लंबी story चली जाएगी. मैं सिर्फ regular shapes पे ले रही हूँ. There are 3 regular shapes: a regular triangle, a regular square, and a regular hexagon, which tessellate in itself. Why they do it is also a bit of small little primary mathematics, really primary mathematics. Angle sum property पढ़ना है और कुछ नहीं पढ़ना है. There are many articles that you can read, or I'll post you, give you my articles which I've explained in a couple of magazines, mathematical magazines. And some shapes do not tessellate, like a regular pentagon will not tessellate, a regular octagon will not tessellate. So overall, we know that there are only 3. By some very small preliminary primary mathematics, I can prove or I can tell you that only these 3 shapes tessellate in itself: a square, a regular hexagon with itself, and a regular triangle with itself. Now, if you look at these shapes, they also have a symmetry in itself. So a square has a rotational symmetry of order 4, a square has a transitivity symmetry, and so on and so forth. So if you go on tessellating a square tile, you are bound to see rotational symmetry and you're bound to see a translation symmetry. However, if you look at hexagon, only the tessellation of hexagon, it only works in terms of a rotational symmetry of order 6. And triangles also have a rotational symmetry of order 3. So if you're looking at that, and if you look at, if I do some bit of tweaking in these parent tiles, इनको थोड़ा सा मैं इसका थोड़ा सा पीस निकाल दूं और कहीं और लगा दूं और फिर उसको कुछ कुछ करूं, तो इनसे जो modified tiles होंगी वो भी tessellate करती हैं. And I can, it's small thing, but I don't have time. I will not go into that. लेकिन अगर हम थोड़ा सा भी इसको tweak कर दें, तो वो फिर अपने आप में beautiful tiling patterns बना लेते हैं, जो मैंने आपको starting में दिखाए थे. जो नीचे वाला अगर आप देखेंगे, जो जिसमें green and yellow and red and white tiles, जो glazy ones हैं, they are actually modified from triangles. So if you take a triangle and you nibble out some piece and you stick it somewhere else, and then you say, so if you see the center point, it has a rotational symmetry similar to the triangles. But if you see the tiling pattern of, let's say, where the legs are, where you can see the feet, that has a rotational symmetry similar to the rotational symmetry of a regular hexagon. So one can make, or you can make a conjecture that this has probably been made from regular hexagon, and which is true also actually, by the way. Anyways, so yeah, so if you study the properties of the shape, then you can understand the properties of the tessellations. And now if you can join other shapes, then you get other beautiful patterns like this. Now this is work of my students that I'm showing you, that we created more shapes. Now agar hum un shapes ko thoda sa unke beech mein joining shuru kar de, then we get tessellations like this. And then we started drawing, and then we started erasing some part and adding some part. So the last 2 pieces that you see on your right are basically on the tessellation pattern. We are talking about circles. If I made the largest circle within a shape and I erase the shapes, then the extreme right hand side is actually a tessellation of circles. And I'm going to talk about maximizing the space, between these circles and जहां से वो बने हैं. तो वो जो आपका, अगर आपको सिर्फ राइट साइड वाला जाली का पैटर्न किसी घर में दिखेगा, तो वो भी इसी सब शेप से आया है. So all in all that I want to tell you is this connection of art, again a multidisciplinary perspective, but building up on the realms of a disciplinary approach of doing mathematics. It cannot be divorced from that. You have to bring up first the study of shapes, then you connecting, and then you bring up these patterns, and then you go back to it. ये कैसे आया, इसमें shape कौन सी होगी, इसकी maximization कैसे होगी, और फिर वो हम daily use में use करते हैं. अगर आपने देखा होगा, if you're living in northern belt of India, in this season, particularly in January and February, in these winters, we get a lot of cauliflowers. And people who are from northern belt would know that, when the cauliflowers are transported from one place to another, they are stacked. And you don't wind them, there's no dhaga ya koi rassi se banda nahi hota hai. They are so closely packed that they do not move, they do not fall apart. And they're transported like that, which means that the shape of the cauliflower is so very, they're fitted so well they do not fall. They're not joined by any rassi, लेकिन वो इतनी अच्छी तरह से fitted होते हैं. The fitting is so strong that they don't fall off. Similarly, spheres, when you put them, juice निकालने, juice shops में आपने देखा होगा कि वो oranges, they are stacked, and they are so stacked so beautifully that they don't fall off. What is being done? Understand ऐसा क्या हो रहा है, कौन सी ऐसी shape से वो कौन सी ऐसी binding वो है जिससे वो कर रहे हैं, और वो फिर आपको स्टडी ऑफ क्रिस्टल्स पे लेके जाता है. जब आप क्रिस्टलोग्राफी पढ़ते हैं, केमिस्ट्री के स्टूडेंट्स पढ़ते हैं, तो वो यहीं से आता है. टेसिलेशन के आइडिया को जब हम 3 डायमेंशन में लेके जाते हैं, जब हम स्टैकिंग ऑफ शेप की बात करते हैं, तब आपको क्रिस्टल समझ में आता है. इफ यू अंडरस्टैंड द शेप ऑफ द क्रिस्टल्स एंड देन यू अंडरस्टैंड हाउ दे आर बीन स्टैक्ड एंड व्हाट मेक्स अ स्ट्रॉन्ग क्रिस्टल, so then that field gets opened. So this is a small background to chemistry, to art, and going up and down from mathematics, taking from art, bringing to the mathematics, taking it from mathematics, throwing it back. Okay, let's do one more. Shall we do one more commercial break? I think I can skip this. I'll skip this. I'll go to the next one. This is an interesting one. You can watch. Sorry.
No, ma'am. I said this is interesting because I've also seen it.
Okay. So another teaser on mathematics and shoelacing. This is also one of the tails one, and this is one of my favorites as well, because while making these, I learned a lot of things. So let me just open this. Okay, I have to stop sharing. Top and push the lace in a crisscross manner. The zigzag end pattern. One end runs from bottom to top, while the other end zigzags through the remaining eyelets. Okay. So let me start it from the beginning. Is it visible?
Yes, it is visible.
Is this visible? The video is visible. Can you see the shoes hanging?
Yes.
Yes, ma'am.
Okay. So here it goes.
Today we are going to do some street maths, but first let me tie my shoelaces. I just realized that the shoelace style in both my shoes is very different. In one, there is a N zigzag pattern, while in the other, there is a crisscross pattern. And so I wonder, do mathematics have a role to play in shoelacing as well? In how many types can you lace your shoe? And which of these will give you a better fit? Which is more comfortable? Do you have a mathematical eye?
Okay, so the question is, I'm sure this is not easy. You cannot give an answer right now. How many ways can you, how many patterns can you create on your shoes? That's the first question. So you're talking about combinatorics. Also, the most, in fact, इससे ज़्यादा जो ज़रूरी है, इतने patterns जो आप बनाएंगे, उनमें से सबसे बढ़िया fit कौन सा देगा आपको? कौन से ऐसे जिसमें आपका shoe जो है, it will give you a comfortable fit. Is there a connection? Okay, so I think I cannot leave it that open for the people to answer, because to calculate the number of styles is also needs a bit of thinking. I think I'll move on. I'll continue with the video.
Bukart Polster, a mathematician, has actually written a book on shoelacing, in which he has given a wide variety of shoelacing styles. Let's discuss some of these in this video. I'm going to discuss 3 most common styles which are used for lacing the shoes. Firstly, the crisscross lacing. The most widely used style of lacing is the crisscross style. We start from the top and push the lace in a crisscross manner. The zigzag end pattern. One end runs from bottom to top, while the other end zigzags through the remaining eyelets. This style comes as a factory setting, therefore it is seen in most of the shoe shops. This style was also commonly used in some military regiments long time back, because if your foot gets injured, you can just swipe it off. Straight European lacing. In this style, the laces run straight across on the outside and diagonally on the inside. Although this is a visually messy style, but the zigzag on the underline makes it a very comfortable and holds the foot together, whereas the upper lining gives it a very neater look. You will be interested to know that if your boot has 6 pairs of eyelets, you can actually tie them in 43,200 different styles. How many of these have you tried till now? Go on. 1, 2, lace your shoe.
Okay, so before it starts again, I need to close it. Right. So this was about shoelacing. There is also a very interesting way of tying your ties, knotting your ties. There are many ways in which you can, knot your tie and bring up and down. So it also has, again, as we were discussing about I was discussing about the cultural mathematics, and I discussed, in the military style, if you look at, they had a particular way of tying the shoelaces, because if your foot gets hurt, then with just a swipe of the lace, it can entangle itself and your foot can be set free. So there is a story behind it, behind shoelacing also, that, and the factory setting, because they have to, in the shops, they have to keep on letting people try and untie, so they use a different kind of styling to lace the shoe. So that's very interesting that there is a need, there was a process, there is a need to use it. And when you're doing it something formal, then on a formal suit wear, which is of course quite British and quite European, then you had a very formal way of tying your shoes, because it looks neat on the top and the messiness remains underneath the shoelacing style. So and you can bring out various ways on which this is done. Any questions, or shall I move ahead? You can go back.
No, ma'am, no questions.
I think we have time to take questions. What is the time? 5:20. Okay. This is till 6 o'clock, right? So I'll take 15-20 more minutes to finish my presentation. I'm sure there'll be a lot of questions people would have asked. Please note down your questions and your observations. I'd be very happy to take them. Okay. Okay. Now an important part about politics of mathematics. Whose mathematics is it anyway? Is it my mathematics? Is it Greek mathematics? Or these ethnographic mathematicians that we talk about, can we take their mathematics also? So I'm going to tell you a small short anecdote, which will help you to connect that, what kind, this is also for mathematics teachers, how can we question the mathematics in itself? So let me take an example of a mason. When you build your house, तो जो घर में आपके काम कर रहे होते हैं, अगर आपने घर कभी बनवाया है तो आपने देखा होगा कि वो घर में काम कैसे करते हैं. अगर उनको कमरा बनाना है, your rooms are basically rectangles, right? Squares or rectangles. And how do you see, in school, when we are taught about making a rectangle, the definition of a rectangle is derived from the idea of parallelogram, which means you should have the idea of parallel lines first. Then you talk about the distance between two parallel lines, and that's how you build up your idea of rectangle, which means the idea of parallelism is important to understand the definition of a rectangle. अगर ऐसे होता तो हमारे जो मेजन्स थे, जब वो घर बनाते तो वो 2 पैरेलल लाइंस पहले बनाते, ये पैरेलल लाइन बनाते, वो पैरेलल लाइन बनाते, और फिर वो कहते हैं अरे जी रेक्टेंगल बन गया. लेकिन ऐसा होता नहीं है. मतलब उनकी जो बेसिक डेफिनेशन है वो पैरेलल लाइन से नहीं आई है. आपने अगर उनको देखो तो वो क्या करते हैं, दे टेक 2 threads और 2 सूतलीज, they tie it up from the middle and then they stretch them, they stout them. All right, they straighten up them, and when they get stout, then they mark their points, right? So it comes like this. So these sutlis, which are tied up in a crisscross way, get stout, and then they mark these 4 points, and that's how they start thinking about this as a rectangular plot. The question that I throw you here is, their basic understanding of rectangle is not coming from the basic understanding of what we have learned in terms of parallelism. their basic understanding, or so-called, like I can call a definition of triangle, has come from the idea of diagonals. So rectangle for them is a closed figure in which the diagonals are equidistant, in which the length of the, or the midpoint of the diagonals, is equal, and then you make a rectangle. So this is, for them, the definition will come from here, and for us the definition comes from the parallelism. So an important point to think about here is, can we change it? If we have to take a perspective which is broader, multidisciplinary, then we have to open our eyes to looking things in a multi-perspective way as well, which means we'll have to look into the definitions and underlying assumptions and see it from someone else's eye also, or the historical eye also, or the other eye as well. कि हमेशा हम पैरेललिज्म से ही रेक्टेंगल क्यों पढ़ाते हैं, अगर डायगोनल से पढ़ाएं तो क्या मजेदार होगा, और होता भी बहुत मजेदार है. मैं अपनी क्लास में यूक्लिडियन ज्योमेट्री नहीं पढ़ाती, मतलब मेरी क्लास इन द सेंस आई टीच पीएचडी.
सबसे अच्छी ये बताया मैं मापदा पापा से 2 शेयर्स में, जब पापा ने करी तो मुझे बस टोटल पता था.
पापा तूने पापा से सबसे पूछा तो होगा.
Any question, is it?
No, ma'am. Some participant had put their mic on.
I thought there's somebody who wants to say something here. Okay. So, where were we? Yeah. So I was talking about that we need to think from that. So I was saying that when I deal with my students, in my BH students, I don't teach them Euclidean geometry. मैं उनको नॉन यूक्लिडियन ज्योमेट्री से शुरू करती हूँ कि चलो नॉन यूक्लिडियन, एक स्फीयर लेते हैं, एक फुटबॉल लेकर आओ क्लास में अंदर, या बास्केटबॉल लेके आओ, चलो क्लास के अंदर बास्केटबॉल लेके आइए, उस पे ना 3 पॉइंट्स बनाइए. ठीक है, आपने 3 पॉइंट्स बनाए, आप उस बास्केटबॉल के जब आपने 3 पॉइंट्स बनाए उनको आप ज्वाइन करिए. ज्वाइन किया तो एक आपकी वो बल्ज आउट वाला एक ट्राइंगल बनता है, राइट, ऐसे स्वोलन ट्राइंगल बनता है. फिर मैं उनसे पूछते हैं आप बताओ कि इसको हम ट्राइंगल कहेंगे कि नहीं कहेंगे. जो मतलब बॉल थी, जो हमारे पास स्फीयर था, उसके ऊपर हमने 3 पॉइंट्स बनाए, उन 3 पॉइंट्स को ज्वाइन किया, एक ट्राइंगल जैसी शेप बन गई. अब बताइए कि इसको ट्राइंगल कहेंगे कि नहीं कहेंगे. दैट्स अ सिंपल क्वेश्चन दैट आई आस्क. देयर आर यस, नो, मे बी. देन आई आस्क देम कि अच्छा ट्राइंगल की डेफिनेशन ढूंढ के आओ क्या है. So then we try to get, several definitions of a triangle, what a triangle is. Then we see if what we've done on the sphere, does it hold to this triangle definition or not? So the definition of the most simple definition of triangle is that it is a closed figure which is made by 3 non-collinear points. तो non-collinear points यहाँ भी थे और हमने join कर दिया, तो अब इसको आप triangle क्यों नहीं कह रहे? Then there is yes, no, debate, there are confusions, so on and so forth. So, I love my classes when students come up with these yes, no, maybe. मैम ऐसे भी तो हो सकता था, इसका sum of angle of triangle जो होता है वो 180 नहीं आता. तो मैंने कहा वो तो definition ही नहीं है, definition में आप sum of angles की तो बात ही नहीं करते, बेसिक अवधारणा से या बेसिक definition से बात करते हैं. If it is joining, if it is matching correspondingly 1-to-1 to that definition, can we call this figure a triangle or not? Let's discuss that. And it brings out beautiful, conversations and debates. So they try to understand that how the concept of triangle is, what is it, what is a quadrilateral, what would happen if I make a quadrilateral on a sphere. Just imagine. Okay, मतलब यही तो mathematicians ने किया था. Imagine करो, ये नहीं तो वो नहीं तो ये change कर दिया तो कैसे हो गया. अब ये surface नहीं है, कोई और surface ले लेते हैं, एक concave surface ले लेते हैं. Concave surface होगा तो triangle कैसा बनेगा, quadrilateral कैसा बनेगा, होगा भी कि नहीं होगा, पहले तो ये सवाल है. So we take shapes and we talk about, we bring out mathematics from there. Okay. Last on my teaser, and then I'm going to go to part 2, which will I take 15-20 minutes to sum up these basic, like I told you, I'm going to share a buffet of ideas. This is one another idea, and I think this would be the last video of mine. And then I'm going to discuss about pedagogy that needs to be adopted for imbibing multidisciplinary approach. So just give me a minute, I'll share. Mathematics in kitchen is very famous, and we all know that, a lot of schools do.
And here's the second cake to
Mathematics' kitchen is very famous. We know, how we talk about proportions, we make various recipes and use a lot of, but this is something different. This is also related to shapes. It's something different to do with the proportional aspect of mathematics. Let's see how you cut a cake. So that's the idea, cutting a cake, mathematically cutting the cake.
Who doesn't like to have cakes? But what if I tell you that cutting the cake also involves some mathematical skills? There are good ways of cutting a cake and there are not so good ways of cutting the cake. The traditional way or the classical way of cutting the cake is by doing a wedge or making out a sector. So when you cut the cake, usually you put your knife in the center and you take out a wedge from it like this. Taking out the wedge or a sector like this part then gets exposed to the air and loses its moisture. Can you think of another way of cutting the cake? A way in which there is minimum exposure of the surface so that the cake doesn't get dry. Can you think of a mathematical way to cut the cake? While you think of so, I'll go and bake another one for you. And here's the second cake to demonstrate the second method. A British mathematician, Galton, said in the famous magazine Nature that to his amusement and satisfaction, the ordinary method of cutting out a wedge is very faulty. He proposed another way to cut the pieces so that the remaining pieces can be co-joined to give least exposure. And this was his method. So here's my cake. And I'm going to slice it from one chord. Parallel to it, I slice it again. You take out the slice and eat the cake. The remaining part can be joined so that there is least exposure. Now when you join this, you can keep it together or put a rubber band around it so that it doesn't get exposed. Next time when you have to cut the cake again, put another slice here. The next one parallel to this. My cake is a bit crusty, so it's crumbling. And you have these pieces. Co-join the remaining part. You would see that there is least exposure to the surface and it remains perfectly moisture. Well, whatever the procedure may be, cutting the cake has to be a cakewalk. And I'm going to enjoy it.
Okay, so that was my last one. So let me just close the other things which are open. So this was again a scientific process so that you don't lose the moisture in the cake and it doesn't get dry. I don't know if anyone of you have ever come across this idea earlier or not, but now everybody at my home only we usually, when on the birthdays, when we cut the cake or when we have to store it, we try not to cut a wedge and we store it like that. So this is just just for fun actually. Okay, so let me go back now. So we've understood how maths is so many things. It's related to art, to I think I've shown you things on sports, on art, on even science, or even mathematics, like the shapes itself, and why we need to take a multidisciplinary perspective. So what can we conclude? For multidisciplinary, it has to be a mindset. There is nothing called this is multidisciplinary mathematics. It's the way as teachers we take things in our classroom. It's up to us how we create connections. So it is connecting the multiple aspects of mathematics to the classical or the formal knowledge of mathematics so that the subject no longer remains to be an uncharted territory. If you understand, I mean, this is my own words, if you understand, this is Gandhism, by the way, sorry for this little pun. I just want to say that, if you have an open mindset of connecting things, then all subjects are connected. Why even mathematics? Science, arts, every subject is so well connected that one doesn't have to take only maths from a multidisciplinary. I think when you're talking multidisciplinary, it means multidisciplinary, which means you take things, in some aspects, one discipline will dominate on the other, and another thing, another episode, another thing will dominate. But if you're talking about in terms of mathematics per se, then your thought, or as a teacher, your thought should be to connect mathematics more and print out examples. Like, for example, the examples that I've made, irrespective whether it was cutting a cake or going to or thinking about animal tails or whatever, I have looked at from a mathematical perspective, mathematical eye. So bring out the mathematics from that and bring situations for these students so that they can understand, they can relish, they can enjoy mathematics. Several times, as maths teachers, and often we get this question, uh, you know why are we studying this? How is maths related to real life? I think I'm not satisfied. I'm not happy with this question. You study a discipline or a subject because it gives you thrill. I do not have to come to that stage of giving an answer to this question. I'm doing mathematics because I enjoy it. I don't have to find its application on whatever I do. The application may not come. But as teachers, you need to think about where you can maximize these opportunities for students. So this part 2, where there's only 2-3 slides, is just kind of summation of the pedagogy. In simple terms, the pedagogical aspects that you should look out while doing mathematics is that you need to keep in mind the context of your learners. You are the best judge to understand the background of the learners in terms of their social background, economical background, or even mathematical background. So you can have, it's like now we know from online classes, we know everything is so convenient. We've got an access to so many things. There's so many YouTube people, there are so many videos. It's just how you take these opportunities and understand what goes well for your students. So it's only a teacher who can understand the context of the students and then connect ideas from there. You have to understand that it is also, your pedagogy is also age and grade dependent. All these examples that I've done, I can do it with class 3. I can do it with I created these videos for general public, all right? But I know that when I'm talking about differential equations, and if I have to take this example to my graduate students, I have the avenue of doing it. There is a scope. Similarly, for biomedical students, we can do it even for them. So the pedagogy has to be such, you're the best person to understand and grade your pedagogy in terms of the level of your students. So, or tessellations, for example, I know people do it with class 3-4 students. They give them small projects on doing tessellations, to even high school mathematics. I can do it even with high school tessellations. And it has to be content dependent. So keep in mind what content you're doing. Let's say Pythagoras, then pick an example of Lazarus. Or if you're doing number system, then why don't you pick various kind of number systems from the historical perspective? If you're doing, let's say something based on linear graphs, then pick up examples from optimization, the thoughts from optimization. Create your questions around that. Create your pedagogy around that. So these are the things that you need to keep in mind. Textbooks, however, will not give you clear-cut answers. There is a limitation to the textbooks. Textbooks cannot give you all these. This is on the teacher. This is the pedagogy of the teacher. To connect the textbook with the learner is the role of a teacher. And finally, what can you do to have multidisciplinary approach in your classroom? So these are some of the examples. You may call it projects. For example, you pick and give projects to your students. You can even talk about thematic learning. By the way, on thematic learning, I would like to share these 2 examples, which I've quoted here. Project on functioning of railways and water harvesting. These are two thematically learning projects that we had actually done with our students, because before doing it with school children, we thought let's do it with our own B.Ed students. So a couple of my colleagues and we got together and we started looking at, we had a language person with us, we had a social science person, all our teacher educators, these were all teacher educators. We sat down and we identified certain themes in which we can bring it up in a multidisciplinary perspective. So there was language in it. These are two examples that we could, work on. And then we tried to create some booklets on, we even moved to the level of assessment. So the project on railways was really good. I mean, there was so beautiful. Students had to make awareness-based posters in it, so it worked the idea of language in it. Then they had to study the nitty-gritty of the railways. They had to understand the combinatorics. Then they had to make announcements. So they were talking about language. They had to look into the upstream and the down. So they are looking at the geographical aspects of railways as well. Then they were making timetables, and so we asked them, okay, let's say if we are given a project on to do something for the railways, what all things that we do. So this came out as a thematic learning project, and it came out very beautifully. I know some of the schools who follow this approach, some of these so-called innovative schools who follow this thematic learning approach. And some of the people who do homeschooling primarily follow thematic learning approach. The third is a research-based approach, where you pick up examples or real life context and you start talking about them. You research, which means maybe you're not coming up with something new, but you may only be talking about something which already exists. But you take it in a research manner. You experiment, you make hypothesis, you make a conjecture, then you talk about it, then you build it up like a research idea, and you take it ahead. More on these ideas are they're available everywhere. I don't think we can I think Xavier's Institute would definitely think about having more sessions or dealing only with these, that what do you mean by a research-based pedagogy, what would be a thematic-based pedagogy or a project-based pedagogy. These are different styles or different ways of looking at pedagogy, but worth discussing, and some of the ways in which you can take multidisciplinary approach ahead. So finally, my last slide. I think I'm on time. So finally, I conclude that your students should be given an apprenticeship of thinking mathematics, which means, if you understand what you mean by apprenticeship, is you start thinking, you bringing up, you work in that area, and you are kind of, it's like hands-on process which goes on and on. So to do mathematics, you have to not treat them as students, you have to treat them as apprentices who have to think in a certain pattern and take it ahead. So I think I end my presentation. We have around 15 minutes for discussions, questions, and certain sources I need to acknowledge for the pictures that I have taken. These are, I need to acknowledge the sources where I've taken my work from. Okay, so we can invite discussions. I'll stop sharing my screen now.
Yes, ma'am, we have some questions here.
Yes.
So the first question is, how was zero symbolized as shunya? Is there any spiritual connectivity to it?
It is, but मैं अभी क्यों बताऊं आपको? Yes, it was. Yes, there is history, but I think we'll divert from the theme of today's work. Talking about zero is another way, because then we'll have to talk about place value and how the concept of shunya was there. Is zero a placeholder or is it a number? We have to deal in all this. So that's a long, not long, but I need at least 15 minutes because to do that, I have to first tell you कि place value क्या होता है, place holder क्या होता है, और number क्या होता है. इन तीनों का मुझे थोड़ा सा बैकग्राउंड बताना पड़ेगा, मैं तभी बता पाऊंगी कि जीरो को हम प्लेस वैल्यू मानते हैं, नंबर मानते हैं या प्लेस होल्डर मानते हैं, और शून्य या वॉइड को हम क्या मानते हैं. तो I don't think so. I would go into that right now because that's letting off the of the webinar, of the theme of the webinar.
Okay, thank you, ma'am. So, ma'am, the next question is how to search relevant activities on each and every topic in mathematics,
Why do
especially
you
for
have to?
for topics such as matrices and determinants. That is what the participant is asking for, especially topic as matrices and determinants.
Okay. I think I said this in between that first of all, you don't have to get into this rat race of finding a real life example to every abstract concept that you're teaching in mathematics. Please remember, mathematics came as an abstract subject. However, coming to your answer on matrices and determinants, there are a lot of real life examples. Matrices and determinants emerge from the idea of symmetry. तो क्लास 7th में जो सिमेट्री पढ़ी थी, पहले तो आप मेट्रिसेस एंड डिटर्मिनेंट को वहां कनेक्ट कर सकते हैं कि अगर आप ट्रांसफॉर्मेशन कर रहे हैं, ट्रांसलेशन करते हैं, तो वो कैसे कनेक्ट होता है. तो छोटा एग्जांपल तो क्लास 7 से ही कनेक्ट कर सकते हैं. आपको ऊपर जाने की मतलब बहुत कॉम्प्लिकेटेड एग्जांपल देने की जरूरत भी नहीं है. यू कैन स्टार्ट फ्रॉम सिंपल थिंग्स दैट you've already done, mapping and taking connections from there. And matrices and determinants, to answer a question where you can find, well, as I said, there are a lot of things on the internet. Some of the things I could not access my library in the last 7-8 months, and I'm missing that. But I learned a lot of things from the internet itself. And if you do a sensible search, you will definitely get. There is no. You will definitely. It's like Bhagwan type से मिल ही जाते हैं कहीं ना कहीं तो. So I would say that there are a lot of. So if I go on to answering on matrices, the next question would be on Pythagoras. So I can't list out, and I shouldn't be listing out. That's not what I should be doing, that I give you a list of activities with every concept and map it to that. You will look at it. You will get many answers. Look into the context of your learners. Some of them you may not even like to use it with your learners. Please remember the 3 points that I shared with you: context of your learner, age specific, and content. And then search for an activity. For any specific thing that you need, you can email it to me. But first, look at internet.
Thank you, ma'am. Ma'am, the next question is, which are the best websites to get activity-based examples?
Lots. There is Enrich, N-R-I-C-H. There is NCTM website. It's called Illuminations, which is by NCTM. Sorry, 1 minute. Go to the repository of NCERT. I think they have a beautiful connection. NCERT की अगर आप वेबसाइट पे जाएंगे, वहां पर रिपोजिटरी है. उन्होंने बहुत सारे वेबसाइट्स वहां लिस्ट किए हुए हैं. NCERT की भी और NCTE की वेबसाइट पे भी they have created, something that happened good during this pandemic is lot of organizations, and I'm sure your organization would also take a similar exercise. They created, even we created so many things. We made a list of so many things on our website through, which we were sharing it with our students. So look at NCERT. They have a repository of websites there. And many other educational organizations are doing it, and it's just a matter of searching. If you want a collection, go on to these authentic government websites, government education websites, and you will find it.
Ma'am, the next question is, any books or mathematic magazines or journals that you would like to recommend?
Okay, surely. Let me begin with Indian. There is a beautiful journal magazine actually, or a journal you may call it. It's called At Right Angles. It is by Azim Premji University. Some of my Tesla, I've got 3 articles on Tesla. In any case, you will like that magazine because, it is freely downloadable from their website. It's called At Right Angles. I would highly recommend that magazine because it has lot of resource. It's a resource magazine for mathematics teachers. It has pedagogical examples, even examples. They have a problem solving session where they're talking about questions as, for Olympiads. Then there are other, in India, that's the magazine that I would like. There is a Resonance magazine, which has also come up. There is an organization called MTA, which is called Mathematics Teachers Association, which is also Indian. These are Indian resources. Homi Bhabha has brought up a lot of stuff. Homi Bhabha have their own website. They also keep curating stuff. And then if you go for international magazine, there are many by NCTM, that's called National Council of Teachers of Mathematics. They have a lot of magazines related to, but they're all paid, so you'll have to give them a subscription cost, and you can subscribe to it. It's called Mathematics Teacher, Journal for Teaching of Mathematics. These are some of good journals and magazines, but they're all paid. And internationally, they're all paid.
Thank you, ma'am. Ma'am, we'll take this as a last.
I forgot to answer. I forgot to add Vigyan Prasar. Vigyan Prasar has also come out lot of repository and lot of things on mathematics, many subjects actually.
Yes, ma'am. Ma'am, we'll take this as a last question. So, ma'am, the question is, the participant says that he loved the activity of shoelace, the shoelace activity, and he's asking that how can we relate the shoelace activity to school math?
Combinatorics. Simple.
Okay, ma'am. Ma'am, thank you. That's all from my side.
Hello. Hello.
Yes, Father. Yes, Father.
I would like to say something
Yes.
for attending this thing. I'm not a mathematics student or wizard, but I learned something very, very precious from this, which is from all that you presented in terms of the interrelationship or interconnectedness in a multidisciplinary approach to mathematics, or using mathematics as a multidisciplinary tool even. And that is something which is, for me, has been something very dear. It has shown to me that there is a harmony in reality. It's a blend, this interconnectedness or interrelationship is a blend of different subjects, different fields of knowledge that makes the whole richer than the individual part. That's what I am seeing from whatever you have presented to us. How through the geometrical shapes, blending one another, complementing one another, complementing different subjects. And I think this, in a way, has to be the goal of all education, that it leads us to a situation of understanding that there is an interrelationship and an interconnectedness, not only between in different spheres of knowledge, but between ourselves, that we have to learn how to blend with one another and to create a situation of harmony. I think this is what I was seeing in a way through all this blending that you were trying to show to us. I think it was very, very, very perceptive also of you to bring that into real life. How is mathematics related to resolving problems in real life, in whatever fields they are? Can we blend them together so that we have a whole that is not just what you call isolated different parts, but they are all interrelated and blend together to create a beautiful world of harmony for ourselves and for everybody around us, with the environment also, with ecology also. That is what I learned from what you are saying. So thank you very much, Haneet Gandhi, for giving us these insights.
Thank you for this aspect. I had missed philosophifying mathematics. You added that to it. Thank you, sir. Thank you.
Father Blaise D'Souza is our manager of St. Xavier's Institute of Education. And Father Blaise is from the Jesuit community. He's a Jesuit priest. And thank you, Father, for your insight. And it was very motivating that you added these points into the webinar. So thank you, ma'am, for an excellent session. I think we really enjoyed every bit of it. And the effort you have taken to make those videos so interesting, and and those small videos, but it was so meaningful and so interesting, and we learned so much from those small videos. I keep on telling in every webinar to all the participants that if there is any innovative strategy, please send us a 1-minute video. But in 2 minutes also, you have taught us so much. I was asking only for 1-minute video. If anyone would send us, we give our email ID. So we are also encouraging these small videos through our webinars, and we thank you very much. And we go to the next part of the session, where we conduct a small research, ma'am, and our students will be presenting the results. So quickly, we will be presenting the results of the last research which we have done. So over to Alsona and Wasim for this session.
So the first question of our survey is, mathematics is a difficult subject for students. And the response for these questions are, so there are 39.2% people who have agreed for this. Next question. Mathematics is abstract, so students do not feel connected to the subject. So here we can see there are 35.1% people who agree on this. Mathematics consists of problems which gives a negative impact to the student's mind. So many people disagree on this, that is 48.6% people. The focus of mathematics is rigid and rule bound, which does not give flexibility to students, which could affect creativity. So there are 39.2% people who disagree on this. Students are reluctant to spend time and efforts towards mastery of mathematics. So here we can see that 43.2% people agree on this. Mathematics as an option for career is not promoted in schools. So 41.9% people agree on this. There are too many concepts.
Wasim, we cannot hear you.
Hello, can you hear me?
Yes, yes.
So there are too many concepts to remember in mathematics, and students feel stressed many times. So 52% people agree on this. Next question. Mathematics becomes difficult for self-learning and constant assistance is required. So majority of the people agree on this, 41.9%. Teachers themselves do not know of the prospects of mathematics as a subject. So people are neutral on this concept. Over
Yes,
to you also.
yeah, thank you, Wasim. So the next question is, there is no available literature about mathematics innovations. And we can see that almost 39.2% of participants have disagreed for it, whereas we have almost equal number of participants who agree and are neutral about this. The next question, teachers are not promoted to participate in mathematics workshops, conferences, or any other professional development activities in mathematics. And we can see that maximum of them, 37.8% respondents have disagreed to it, whereas 24.3% are neutral and 27% agree for this statement. The next, mathematics Olympiad is promoted in educational institutions. And more than 50%, that is around 59.5% respondents have agreed that yes, it is being promoted, whereas almost same number of people are neutral and strongly agree for this as well. Co-curricular activities in mathematics are not encouraged. And we can see that maximum participants, that is almost around 35.1%, disagree and say that co-curricular activities are encouraged, whereas 29% of participants do agree that co-curricular activities are not encouraged. Students are not encouraged to develop creative projects in mathematics, and around 40% people, respondents have agreed for it, that yes, they are not encouraged, but we do have 33.8% respondents who have disagreed. Next, students are not interested in knowing how mathematics can be helpful in vocations, and maximum percent of respondents, that is 45.9%, feel that yes, students are not interested in knowing how mathematics can be helpful in vocations. Next, exhibitions of mathematical products made by students in schools and colleges is not a regular feature. And again, we can see that 45.9% respondents feel that yes, it is not a regular feature. 23% are neutral about it, and 16% disagree for this statement. Next, experimentation in mathematics is discouraged in educational institutions. And we have 37.8% respondents agreeing for it, whereas 33.8% people disagreeing for it. And lastly was a open-ended question where we asked respondents to give opinions about attitude towards mathematics in educational institutions and about importance given to mathematics as a career options. So I have divided the responses. First, let us look at the responses about the attitude towards mathematics in educational institutions. And sadly, the responses were negative. That is, very few institutions promote the application of mathematics and relating it to real life scenarios, which makes students feel that mathematics is completely an abstract concept, whereas in reality it is not. Mathematics is a very interesting subject, but students don't want to practice it, and teachers don't get time to teach maths in class in creative way because they often have a target of completing their portion at a certain period of time. And next, mostly mathematics is portrayed as a very difficult subject meant for geniuses only in schools. And there is no encouragement to explore. Children are not allowed to make mistakes, and the focus on teaching maths is more on rote learning rather than application. So these responses give the gist of the overall responses that we have received. Next, looking at the importance given to mathematics as a career options, again, we had responses which were negative. That is, as a career, only select schools are interested in doing so. And the reason for that being that the teachers themselves are not versatile and creative with maths as a subject, which is why we fail as educators to pass it on to our students. Various competitive exams are conducted by institutions, but again, no career options are discussed in details. And mathematics as a subject is given highest importance compared to other subjects in school. The reason being that it gives many career options, which increases the analytical thinking, develops confidence, improves decision-making ability. But the overall view of the responses were that not many institutions promote mathematics as a career option. So these were all the responses. And with this, I end the presentation for the survey that we had. Thank you.
Thank you, Alsuna and Wasim. I now invite Clarice to propose the vote of thanks.
Good evening, everyone. So it's my privilege to propose a vote of thanks for SXI Maths Webinar Series 7 2021. On behalf of SXI Manager Father Blaise D'Souza, Principal Dr. Susama Samuel, Staff in charge Dr. Winnie Sebastian, I extend a hearty vote of thanks to a resource person for the day, Dr. Haneet Gandhi, who spared time from her busiest schedule for this webinar. Today, we have been privileged and had this amazing opportunity to hear your session on teaching mathematics with multidisciplinary perspective. The amazing self-made videos that you used during the session has definitely changed our perspective towards math. I'm sure all the information will help us immensely in our respective fields. So thank you once again, ma'am. Next, I would like to thank our manager, Father Blaise D'Souza, and our principal, Dr. Susama Samuel, for allowing us to continue with the Maths Webinar Series 7. I would like to thank and appreciate our staff in charge of mathematics pedagogy, Dr. Winnie Sebastian, for motivating and encouraging us to continue with the webinar series. My heartfelt gratitude to our student coordinators, Alsona, Riesel, Clarice, Rachel, Nisha, and Wasim for being the strong team behind the curtains and providing technical support. And last but not the least, a big thank you to all you participants for your presence. Without each one and every one of you from Zoom and YouTube, this event wouldn't be successful. We hope that you are taking back something with you from today's session. So once again, thank you for making this event a successful one with your enthusiastic participation. With this, I end my vote of thanks. Now there are some instructions regarding the feedback form. The link is already posted in the chat box of Zoom and YouTube. Please note that later on, no link will be posted in the WhatsApp chats. Feedback form will be open only up to 7. While filling the feedback form, participants make sure that you all enter the correct email address. If you do not get the certificate, wait for some time, check your spam folder. Even then, if you do not get the certificate, you can contact any one of the student coordinators before 7. Thank you. Now, Winnie ma'am.
Yes, thank you, Clarice. Thank you everyone for your participation. So that with that we end the mathematics webinar series 7. Have a nice weekend and implement the multidisciplinary approach to mathematics teaching. A special thanks to Dr. Haneet Gandhi. Thank you, Dr. Haneet, for your session. Yeah, bye, Dr. Haneet. Thank you very much.
And do share the feedback that you get. I'll wait to know.
Okay, okay. We will do that. Yeah, thank you.
Thank you. Thank you. Thank you, everyone. Thank you for the institute. Thank you, sir.
Bye,
Thank you.
Dr. Susama, ma'am, you're here.
Yeah, I am here. And thank you so much, Dr. Haneet. It was really a wonderful session and we have enjoyed it. Actually, we wanted more from you.
Well, I hope I did justice even in this time.
Okay.
And,
Okay.
if you tell me anything specific, and if it is within my capacities, I'll definitely.
Yes, really, we have enjoyed your session.
Yes, Dr. Haneet, madam was appreciating your creativity. So, ma'am was saying that Dr. Haneet is so creative. She was appreciating your creativity.
Yeah. Yes.
Yeah, these were all. This is what I learned in the lockdown period, and the lockdown only helped me to hone this ability of mine to create. And you would believe these were all done in long time back, between till June to September. After that, I got so busy with admissions that I didn't. Now again I'll start, but I'm going to bring up more videos, small little videos, only to popularize the aspect. I request the participants to subscribe to the channel. There are few more. There is one particularly which I missed, was on face mask. Why should you use a particular shape of a face mask, and not use the rectangular one? I missed that, but please
can you
go
show
to
now. We will wait. Can you show now, Dr. Haneet? At least
Yes, sure. Yes.
Yeah, just
Yeah.
those who
Okay.
want to wait. Yeah.
Okay. As concluding, I think for Corona we need to.
Yes, you have to wear the face mask. Yeah.
I'll just do that. Let me just open it.
Yeah, sure.
Give me a minute and I'll just.
yes, we can see.
Okay, this is also special because this idea was shared with me to me with one of the people from Jammu region. So this was his idea, and we both of us did this. So I just play it.
Hello, friends. Today's episode is dedicated for public awareness. We're indeed going through a very rough phase. To protect ourselves from COVID 19, we need to clean our hands often, maintain a safe distancing, and use a good face mask. Let's talk about face masks today. This idea was shared with me by a teacher from Jammu region. He explains how a conical mask is better than a flat rectangular mask. I like the way he used minimum resources to make his point. Over to him.
Myself, Muhammad Yunus, teacher high school Sindor, district Punch, J&K. Want to share with you the idea how a cup shape custom like face mask is better than cylindrical face mask made up of cotton cloth. Suppose we wear this face mask, although it covers the whole face, but the distance between the mouth, nose and this face mask is less than as compared to the distance between the mouth, nose and face mask of cup-like face mask. When we exhale air, so it's stuck with this cloth because the distance between the mouth, nose and this cloth is very less as compared to this one. And naturally, the droplets of water can again come inside, go inside the mouth through nose, which can cause this vital disease.
Let me add a few more points. Conical mask, being curved, is less stable for the droplets to stay on the outer surface. Also, owing to its curvedness, it fits better on the face, creating a seal at the nose and mouth. Well, the basic purpose of a mask is to protect you, be it any shape. The idea is to wear a clean mask which is hygienic and covers your face entirely when worn properly. Stay protected and let's pray for the well being of all.
So that was it.
Very good, very
As
good.
a finale, as a finale.
Yes, finale, very nice. Thank you, Dr. Hani.
Thank you.
Thank you so much.
So, ma'am, can I end the meeting?
Yes, I think so.
Bye.
Thank you very much.
Yes.
Yes.
Thank you very much, Dr. Haneet.
Yes, sir.
Very nice, very good. Yeah.
Thank you.
Good evening, everyone. Welcome to the second session of the guide.